Variables. So what is a random variable? A random variable is a function from sample space into real numbers. A random variable takes in the sample space as its domain and give out real numbers as its range. So a random variable is a function. So we have a function is like a machine. So we have like this is a machine here. This is like a machine. This machine we are feeding in the sample space, and now this random variable x, this is a function which it give out real numbers. It give out real numbers. So the function of the random variable is a function that acts like a machine. You feed in sample space and it gives out real numbers. So if we define, for example, if we call x our random variable, when I say we call x our random variable, I mean the function which converts a sample space to real numbers, we call it x. Now we know we define two other things. We have a sample. This is our sample. The sample contains of S1, S2 up to Sn. That is the sample space of the experiment. Then we have the range, the values that we are going to produce after feeding this sample into this machine. We call them x1, x2, x0, or what we call the range of this random variable. Now, mathematically, to define a random variable, it means this function is taking a value from the sample space, then it is giving the value x, which you have said this value x must be a real number. To define it in terms of probability, the probability that a random variable x takes a value x from its range, from this range, is only exists, or it is only given when the value that produced this value x was from the sample space. So this is the simple meaning of that. For this probability to exist, the value that produced the value xi, that is these values, when they were fed to the random variable, they must be from this space. Question 2. Interpret probability of y is equals to x 0.2. Now, y here, when you're trying to interpret this, y here, this is the random variable. And this is what we call values assumed by random variable, values assumed. So this says that the probability that a function which we are calling the random variable, that the random variable y will take a certain value which we call small y, is given by 0.2. So specifically, the capital Y represents the random variable, the function that we have defined. Then the small y means the values that the random variable takes. These are the values that the random variable takes. Example 3, we can check this one. A coin is tossed 3 times. We want to know number of heads obtained. So every time you are given a question, always follow these 3 steps, because these 3 steps will help you to define the correct random variable. So a coin is tossed 3 times. We want to know the number of heads obtained. Keep that in mind. Our aim is to know the number of heads obtained. So what is the experiment? Experiment is the activity, the action you do. So the action that is being done here, it is tossing of a coin. So tossing of a coin, It is the experiment, tossing of a coin. That is our experiment. So, what is the sample space? When you toss a coin 3 times, this is the sample space that you obtain. You obtain a head, 3 heads. You can obtain 2 heads and a tail, 2 heads and a tail. You can obtain again 2 heads and a tail, but in a different version. These are the possible way to obtain this one. So we have tail, head, head, tail, head. Then we have, you can also obtain this one. You can also obtain this one. Also, you can obtain this one. These are the sample space. And there are 8 of them. You can confirm with there are 8 because a coin have only the 2 possible outcomes, 2, and we are tossing it 3 times. So it is 2 power 3. You know the cardinality or the number of elements in the sample space. So 1, 2, 3, 4, 5, 6. There should be 8. This is 7. We have, and then we have the other one. We have the last one that we should have. That is this one should be there are 8 of them. Now you are told to define appropriate random variable and its range. For you to be able, the reason why you are told to define the appropriate random variable, you should go back to the question. The question says, we want to know the number of heads that occur, that happens when we toss a coin 3 times. So the appropriate random variable should be defined as number of heads. So I'm calling my function x, which is my random variable, which is the number of heads obtained. It's number of heads obtained in three tosses of a coin. In three tosses of a coin. Now, what does it mean by saying x, the number of heads obtained in 3 tosses of a coin? It is like you have something like this, y is equals to fx. That is, when you feed the value of this a function, when you feed the value of x, it gives you y. In simple terms, y, it is another name of this function. It is the same case here. Y is a function, and this function is equals to or give the number of heads obtained when you toss a coin 3 times. Now we defined a random variable as a function, and we said the random variable takes the sample space at its domain to give real numbers. So for example, let us feed the sample space to this random variable. So the first sample space or the first outcome is 3 heads. You feed it into random variable x. What does it give? The work of this random variable, it is to count the number of heads in the sample space. So when you feed this outcome into this random variable, it will count how many heads, 3 of them. Then you feed the other one, the other outcome, which is 2 heads and tail. You feed it to this random variable, it will count 2 heads. You feed the other one, it is a head, tail, head. It will give you feed it to this random variable, it will count how many heads, 2 of them. Then you feed it to the other one, it will count how many heads, 2 again. Then you can continue that way. You feed it to tail, head, x will count only 1 head. You feed it also to head, tail, this one, it will count, x will count one head also. And you feed it to tail, head, head, it will count also another only one head. Then you can feed it to tail, 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 and it will only count 0 heads. We don't have any heads. So the random variable x is going to count 0 heads. So this is the random variable we have defined. So the range, what values does the random variable takes? This random variable x takes 0, it takes also 1, and it takes 2, and it takes 3. This is what we define as the range or the sample space of the random variable. The values the random variable takes. It takes either 0, 1, 2, or 3. Now, is this consistent with our definition of a random variable? Yes. We say that a random variable takes in the sample space to give real numbers. You can see all these are real numbers. All these are real numbers. So we are told again, find the induced probability function on this space. So we needed to find the induced probability. Induced probability means we are deriving the probabilities of these outcomes from the probabilities of the sample space. That is why we have the word induced. We don't have probability of 0 occurring, 1 or 2, but we can get this probability of this one from the outcomes of the sample space. So we can write our probability function as the values of the sample, the values that this random variable takes are 0, 1, 2, 3. And the probability that the random variable x takes x value is, so for you to obtain 0, 3 heads must occur. The probability of 1 head occurring is a half, multiplied by the probability of another head occurring is a half, multiplied by probability on another head occurring is a half, which will give you 1/8. So the probability of 0 occurring, it is the same as probability of 3 tails occurring, which is 1/8. Then also, the probability of 1 occurring, it is either this outcome happens, or this or this. So we say the probability of 1 occurring, it is the probability of either tail, tail, head occur, or head, tail, tail occur, or tail, head, head occur. If this probability occur, then a 1 will occur. So we should ask ourselves, what is the probability of a tail, head, tail happening? The probability of a tail happening is a half, probability of a tail happening is a half, the probability of head happening is a half. So the probability of this outcome happening is 1/8. Also, the probability of this happening is 1/8, and this 1/8. You know from the rules of probability, all means you add. And since these outcomes are independent of each other, we just add this 1/8 plus 1/8 plus 1/8. We get this one will be 3/8. The same case will happen. You can fill now for 2 and 3. For 2, it will be 1/8 plus 1/8 plus 1/8, which will be 3/8. And for the 3 heads, it will be just 1/8. 3, only this one will happen, which is 1/8. This is what we call induced probability function. We have obtained the probability of this random variable x, from the probabilities of the sample space. And this is now what we call induced probability function. The other question is about is question 5. A random variable is random. Is it true or false? Pause the video and think for a second. A random variable is random. Is it true or false? It is false. is false. A random variable is not random. A random variable is a function. You see, when we talk about something being random, it means it is something that happens by a chance. But whenever you have an experiment, you are the one who defines the random variable. So that random variable cannot occur by chance, yet you are the one who decides what is the random variable. I hope that's clear. Random variable is a variable, is variable. Variable means it changes. Now, you cannot define a function. For example, you cannot define a function x which counts the number of heads. This function cannot change the way you have defined it. If you have defined a function, its work is to count number of heads. In its eternity, or in its how you have defined it, it will keep counting the number of heads. It will keep counting number of heads. So a random variable as a function is not variable. It does not change because how you have defined it, it stays that way. And the two, it does not occur by chance. So a random variable is not random, and the random variable is not variable. It does not change. So this is not true. This is not true. Both are false. The values a random variable assumes are both random and variable. Is this true or false? It is true. You see, to illustrate this, for example, if you toss a coin 4 times, the example that you have checked, you have tossed a coin 3 times. If you toss a coin 4 times, one of the outcome will be head, head, head. One of the outcome will be 4 heads. Now, the same random variable will count now the number of heads to be 4. It will now take the number of heads to be 4. But remember earlier, we saw the range of this random variable was 0, 1, 2, 3. But by defining a new experiment, the moment I have now defined a new experiment, tossing a coin how many times? 4 times instead of 3. Now the values the random variable will take will no longer be 0, 1, 2, 3. It will be 0, 1, 2, 3, and now the new one 4. Those will be the new values. You see now, these values that the random variable is taking, they depend with the sample space. So 1, they are variable, they change depending on the sample space. 2, they are random, they occur randomly. You cannot say that they occur by chance. Why? The outcomes of the sample space are by chance. For this kind of an outcome to occur, it occurs by chance. Select a song on music player. Define a random variable that determine if a song is rock music or not. So, what is the experiment in this question? Experiment is the action. The action that we are doing is selecting a song. So the experiment is selecting a song from music player. What is the sample space? The sample space, it is what you expect to see when you carry out the experiment. So when I select a song, I expect either to select a rock music or other. That is what I expect. We define a random variable x. You see the question is saying, determine if a song is rock music or not. So we are told to define a random variable that determines if the song is rock or another type of song. So whenever you are told to define a random variable that determines something is one type or the other, that's come with the concept of identifying. So this random variable its work will be to identify a rock music or another music. Now take an example. If I give you a list of numbers like this, and I tell you, identify the odd numbers. So every time you get a number which is not odd, you will put 0. Every time you get a number which is odd, you put 1. In simple terms, whenever you see the concept of determining, of identifying something, we normally use 1 and 0 to identify two types of things. So this random number, because it is identifying if a song is rock or not, we are going to indicate this random variable as number of rock music. So number of rock music. So the work of this random variable its work will be to identify the number of rock music. So if our work is to identify a song is rock music, it means the rock music, every time we identify a rock music, we'll give it a value 1. And every time we identify a song which is not rock music, we give it a value 0. So in this case, our sample space is rock, and when we feed it to the random variable, it will give us 1. It have identified the rock music. And whenever other music is being played, then the random variable returns 0. It is 0 meaning it have not seen a rock music. So every time another song plays, the random variable says, I have not seen any other music. So it returns a value 0. Every time a song plays which is rock, it returns a value 1 saying that is a rock music. So the space of this random variable is 0 and 1. You can see all my random variables and defining them such that they give numerical values. If you ever define a random variable that does not give numerical value, then there is a problem. Now, a friend request is placed on Facebook. We want to know the time it takes for a friend request to be accepted. Determine an appropriate random variable. Now, the first thing is you ask yourself, what is the experiment? The experiment is pressing a friend request. So, pressing a friend request. Now, this question is very specific. It is not talking about pressing friend requests. It is just talking about pressing a friend request. So, every time you press a friend request, there are two things you expect. You expect either your friend request to be accepted or rejected. So your sample space will be these two: a friend request which is accepted and a friend request which is rejected. These are the two possible outcomes of this experiment. You press a friend request, it is accepted or rejected. Now let me define the word rejected. I'm defining the word rejected in this sense that if somebody ignores your friend request because he does not want to accept you, we define it as rejected. So that is why I'm saying it is two possible outcomes. So, and this is very important. So we want to define our random variable that counts the time it takes for a friend request to be accepted. So this one, we will define it time it takes for a friend request to be accepted. And this is now what happens. You see, sometimes to come up with the space of a random variable, sometimes to some people is difficult. Now, if a friend request is accepted, that is the outcome, one of the outcome, then this random variable returns the time it takes to be accepted. Now the possible values of the time is between 0, because you can thread a thread request immediately to be answered, it is 0, and I have put open brackets because we can have it is accepted within seconds, and infinity, but I'll explain infinity in the second. So it is between 0 and another time here, I can call it t. If it is rejected, and this is where I want you to pay attention, if it is rejected, now if a thread request is rejected, the work of random variable is not to count the time it takes a thread request to be rejected. It counts the time it takes for a random variable to be accepted, or for the thread request to be accepted. So if some people will be tempted to say, because it was rejected, it will give value 0. You see, if you write that it gives the value 0, it means you praised the thread request and immediately at that moment it was accepted, because now this gives that the time to be for a thread request to be accepted was 0. That will be the interpretation. The appropriate value to put here is infinity. That is, if somebody rejects your thread request, it will take infinite time to ever accept your thread request. That is, it is time which is unending. I hope you get the difference, why we put infinity, not 0. So this means the times it takes for thread request to be accepted which have been rejected, it is infinity. That is the interpretation. So the space of this random variable, it is the times, it is you join these two, it is the union of these two, union of these two, which gives you 0 to infinity. So the space of this random variable is 0 to infinity. That is the space of this random variable. I hope you get the point. So this is an example of what we call a discrete random variable. It takes discrete values. This is an example of continuous random variables. It takes continuous value, or what we call decimal values, the continuous value. Also, this kind of a random variable here about a song, it is what we call also indicator random variable, because its space is only 2 values. Indicator random variable. This is what we call indicator random variable, or Bernoulli random variable.